All right. Hello, everybody, and welcome to our Python for Finance online bootcamp. My name is Steve, and I'm founder and CEO of the Python Quants as well as the I Machine. I'm pretty excited that so many of you have decided to join us for this event here. The topic is kind of clear. Python as our programming language and the ecosystem, finance as the domain. When people ask me what are you doing, I said, well, Python for finance, right? That's basically my business card and my business purpose, if you like. We do, of course, a little bit more, but at the core of it, it is Python for finance. So I'm even more excited against this background that we are diving into selected details, topics that are so relevant for the usage of Python in the financial domain. Before I get to topics that I've planned for, and this is pretty free, so it's not kind of like a how should I say, a tightly designed set of topics that we're going through, right? We are kind of flexible, and I'm flexible to react also to suggestions from the participants of the bootcamp, right? But before we get into the style, topics, etc. of the bootcamp, let me give you a brief overview of what we are all about. So not everybody who's following along might be aware of everything that we do at the Python Quants and the I Machine. Here you see from another slide deck. That's just for me to have here the introductory slides. The title and the Python Quants, as the name says, I said it, Python for finance. The Python Quants, there should be no doubt what we are all about. We provide services to financial institutions. We run trainings. We run different platforms in the domain. We have open sourced a couple of packages. I've written a bunch of books, and I'm in the course currently of writing yet another book. We provide also certification, and we do events like the one here online, right? 3 days, 3 sessions that we use to go through important topics in Python, NumPy, Pandas for finance. But of course, we run other events as well, such as meetup events, or in the past we have done conferences, we've done live boot camps, we participate in events, and so forth and so forth. But at the core of it, I repeat myself here, is Python is finance, is what we stand for at the Python Quants. And on the side, if you like, it's not fully integrated, but of course, to a large extent, is what we call the I Machine. This is where we have developed and run our proprietary trading platform for AI-powered algorithmic trading. Of course, Python is at the core, but if you want to set up something like this, you need other technologies as well. So we are also going through different technologies that are not maybe at the core of the Python programming language, but that are so useful when you want to apply Python to finance. But this is not here at our core. What this slide provides you with is a little bit more of a detailed background about me personally. I'm not going through this. This is the too long to be read part here, but if you fancy, you can go through that. With regard to the books, Financial Theory of Python, that's the introductory book. That's for somebody who wants to start out in Python, applied to finance, starting out with Python, maybe having a background with finance or the other way around, right? So that's really at the start of a journey into the Python for finance ecosystem. Selected aspects of what is covered in that book will be touched upon at Bootcamp as well, but we will focus more on the Python side, on the programming side, not that much on the financial side. The financial theory part in the title here, which is of course at the core of that book, right? Python for Finance is my thickest book. It's the reference work, right? Mastering Data-Driven Finance, and I'm pretty happy. Just yesterday, I received, and you might see it in the back on my second desk behind me. There is now also a version, and I was pretty excited about that one for a specific reason. It's now also published in French. So Python pour la finance, and this was actually French. I live near the French border, but this was my worst subject at school. I wasn't that bad at school, but French never was something that I excelled at. And now my thickest book, 700 pages, has come out in the French language. So for me, somehow it feels like a circle has closed. But you see there also a Korean version. There are Chinese versions, Japanese versions of this book, and I think a Spanish one, and a few more. So pretty happy that they are now available also in other languages apart from English, right? Here are my quant finance books. So when somebody asks me what my educational background is, my PhD in mathematical finance, and what you can read in these books is, I think, closest to where I'm coming from. But of course, there's a ton of Python. Python is not explained in these books. It's rather like the tool that is used to implement the numerical methods that are introduced against a quantitative background, the financial engineering background. These are more recent books, Python for Algorithmic Trading, Artificial Intelligence in Finance. I think still pretty up-to-date topics. And here and there we might touch upon selected elements out of these books as well. So I was talking about the Discord server, where you please would head to the Q&A channel if you have any questions. I'm repeating this because I know that several people are joining us. So I see again some questions here in the GoToWebinar part. So please post your questions in the on the Discord server so that we can, so to say, archive them and document them. You should have access to the link to the Discord server. But to answer the question which has popped up there, the second edition is, I would say, quite different from the first edition, that's for sure. In particular with regard to the code, but also with regard to the topics that are covered. This was a little bit more than just, let's say, a corrected, updated version. But that's enough, I guess, for what we are doing, where we are coming from, what we provide now to the bootcamp itself. I have only a few slides here, so I'm not going into, I don't know, theoretical side of things with a ton of slides and then a little bit of code. It's the other way around. So basically, to get started with, no theory and a ton of practice, and here and there, as we need, we might add a little bit of theory there as well. So what I've been planning for, and this is pretty much open, but this gives us a little bit of a structure, is that we have the three major topics: Python with regard to the infrastructure, that needs to be set up depending on where we want to work. It's locally, maybe in a Docker container, maybe on a cloud instance, for example. The tools that we use, such as IPython, such as Jupyter Lab, for example, certain Python idioms, data, how do we control the flows or control structures, data structures, etc. Then we have NumPy with the powerful and the array objects that it provides us with. Here I want to focus more on the financial side of things, such as dealing with random numbers, maybe doing, and this is now where I have here the optional topics on the right-hand side, where I'm more or less fully flexible, where we might do some evaluation of options, for example, European or even American options, do visualization and all these topics. And last but not least here, pandas, which has become the core, I would say, of what is done in Python for finance these days, because it's so powerful in that many respects, right? But I think you need to understand the rest here as well in order to make the best out of pandas. In the past, I was saying that pandas in and of itself can be treated as, here's a message from Dropbox, can be treated in and of itself as somehow a closed ecosystem, right? But to have the background, to have more details about how this ecosystem of all the wonderful Python, let's say, methods of the data frame object work, that's, I think, where you get the best out of it. Speaking of getting the best out of it, again, here are the optional topics. What you see here is more or less on a pretty abstract level. Of course, we want to apply this to different financial applications, maybe Monte Carlo simulation, for example, or backtesting, maybe a bit of machine learning, where it fits, right? I'm coming to the approach of the bootcamp in a few minutes. But no matter what we are going to do, and this, as you might have noticed, as of now, is not fully fixed. You will see the results in here. You see the link, and everybody should have received the link to the gist, right? And in the gist, which is currently kind of like in a native state, you see a Python Finance Online Bootcamp. There are, again, all the links, like the short link, which is self-referencing here. Go to webinar registration, one platform, links that are relevant, the slides that I'm using, the Discord server, the mini conda installer that we're going to use, Docker, and here the cloud instance. I'm pretty happy that over time, DigitalOcean, which we use since years now, they have increased their free credit for sign up. So we have like an affiliate link. And when you use that link, you get kind of a decent free credit so that there are no risks involved, or at least, what does it mean, no risk here? So there is no costs involved, right? And you can do quite serious stuff already with the free credit that you get there. So the only thing Python-wise that you see here is a tiny little Jupyter notebook, the first one, right? And as we go, this will grow and grow. The first notebook, then we will have a second notebook, a third one, a fourth. I don't know where we will end up with. So we are fully flexible. I'm fully flexible. And yeah, okay, we can discuss, we can fine-tune, we can correct the direction of what we are going to cover. But this is your primary source. Once you get the one link to this gist, then you find all the other links, just in case you wonder where are the slides again. Discord server. When you're on the Quant platform, you will find there more details as well. But to get started with, the gist should be your, if you like, the base camp from which you reach all the other resources easily, I hope. Again, the message with regard to the Q&A session. If you have questions, please head to the Discord server and use the Q&A channel. It's the second one on the server, and then you should be pull in. You see what I'm showing. Probably you see me here via the video camera recording, and yeah, that should be it with regard to the first administrative topic, so that I can now get indeed here one step further, having somehow clarified as far as possible at this stage what topics I was planning to cover, right? I want to, if you like, do a bit of expectation management. I do this given the years of experience and the feedback from hundreds and hundreds of students, sometimes directly, sometimes indirectly, sometimes in the process, sometimes a little bit later on, let's say with our program, which runs over months, for example. People get immediate feedback, sometimes they get it at the end. Sometimes people hear me speaking just once. So, but let me set the stage with regard to the guiding principles, and they hold true now for what we are doing since quite a while. So whatever we do, it's Python first. So I think that the expectation probably is not with regard to the bootcamp that you will see, let's say, algorithmic trading strategies that you can deploy next Monday, and that will generate cost for you. This is often the case, right? People come to us and say, oh, Python for algorithmic trading, and I say, well, which strategies do you recommend in terms of making a ton of money in a very short period of time? I said, well, we teach Python, we teach you how to do the research, for example, and then you're hopefully in the position to come up with your own ideas, test them, and implement them, right? It's Python. It's Python. It's about techniques. It's about tools. It's about idioms, and everything related to that. Then it's also pretty specific. So I said it, we are not going through a ton of theory. We are concerned with specific implementations of algorithms and examples, right? It's not like that we say like at university, you know, that's the whole universe, and now boil it down. Then we arrive at point number A and B, C, and below B we have 1, 2, 3, 4, 5. That's usually not the case. So we are pretty specific. Then reproducible. There was already one comment on the Discord server at the very beginning with regard to which data source would probably be used. So this is also a lesson learned, and was, I would say, learned in a hard way, that it's difficult to teach people and to have something in a reproducible way when you rely on APIs, in particular on free data via APIs that might change over time, that might be closed, or that might change the coverage. For example, we had this with Yahoo Finance over the years a couple of times. So therefore, I decided a while back, both for the books, for the teachings, for the bootcamps, for whatever I do, that we work with static data files, and that everybody is able to follow along, and not only today, but also next week, and hopefully half a year or a year from now, right? What we are going to do is also practical, right? It's not like that you sit here in a theoretical lecture and you say, well, this is all nice, and next Monday when I wake up, I'm able to do it all by myself. So this is about skills, and my usual analogy is, if you want to learn to play the piano, you need to sit down and play a music piece on the piano, right? Even if you have a wonderful teacher, maybe even Lang, world-renowned piano player, right? And you listen like for hours on end to his excellence and mastery, right? You're probably not in a position to even remotely copy what he is able to do, right? Therefore, you need to practice, you need to do it. And what we do here in a very concise manner, like 3 days for a couple of hours, this cannot replace your own practice. You need to pick out your topics. You need to choose something that is maybe a little bit beyond your comfort zone, but not too far beyond your comfort zone, and then you need to practice, right? That's the major message. If you forget about anything else here, that's the major thing. It's all about practice and not about reading a book or whatever. If you don't like music instruments, think of swimming or driving a car. These are all skills, right? And you need to do them in order to master them. Just reading books or listening to lectures won't do the trick. Also noteworthy, and this is something that I added in particular for this bootcamp, for this setup, what we are going through will be maybe well known for some of you, and might be pretty hard at the same time for others. Therefore, I like here the visualization, right? If you are on top here, you say, well, this is so hard for me, and others say, well, that's low level, that's very easy, right? And for others, they say, well, okay, this was a good refresher, I learned a few more details here, right? But it depends on where you're coming from and how do you experience it. Maybe you say, well, indeed, it's pretty slowly going for me, but then there might be other topics suddenly where you experience a different feeling, or say, oh, this is now new, I need to pay a bit more attention. So this is what you should expect from my point of view, because we have people, and I know that, I'm aware of that, with pretty different backgrounds. So some of them are beginners for some topics, some already experts. So it's difficult to have one setup that fits like everybody's background. Speaking of background, all that I'm going to do will be based on Mac OS, and that's one of the reasons why I also like to use Docker containers, where we'll be working on the Linux shell, right, as well as with cloud instances, where I also work on Linux, so that everybody, no matter where you're coming from, using Windows, using Mac OS, or using on your desktop, maybe Linux already, for example, that we have at least one common denominator. But I said it, or I wrote it in the email, that cloud and Docker are not really necessary for everything else, but learning skills is what this bootcamp should be about. So be game and just give it a try, and later on judge it, right? So often I see people say, well, this is too technical for me, I don't need it, I can get a, yeah, of course you can, but we are not only here to reach a certain goal, but this is again about skill acquisition. This might be quite a bit broader, right? Opportunistic. So I have chosen the dice here as a symbol. It's not that the topics will be fully random, but they are probably opportunistic in the sense that they might fit somehow together, but they are not, again, like what I was saying before, not theoretically comprehensive. So what people say usually, it's kind of like something like MISI, mutually exclusive, collectively exhaustive. So we have the meta topic, and then we break it down in mutually exclusive, collectively exhaustive parts, like a pie, for example. That's not the case. So in the few hours that we have together, that's not possible. Also delayed rewards. Sometimes if I could hear them and not read what they write, I would hear them scream and say, well, that's too fast, I cannot keep up. And what I often say then is, of course, everything is recorded, right? It will be put on the Quant platform, and you can always revisit what we are doing here later on. This is, again, like your teacher, your piano teacher, right, is playing a piece, and probably for the first time when you want to repeat what you have seen before, it doesn't work. So you need to get back, you need to repeat it, you need to get better. And then comes the point, maybe in a delayed fashion, where I say, now I got it, right? So that's, again, in terms of expectation management, don't expect to get through it immediately. Also, what I was saying in the gist, everything that I'm going to do that you might have missed or you haven't been fast enough to follow along will be put on the gist, right? Not every single detail, for example, when we go through the Docker containers, but with regard to the Python code that we generate in the form of Jupyter notebooks, this will all be put in the gist later on, so that you can download it, work with it, change it, whatever you want to do with it, right? So yeah, that's already what I wanted to do as an introduction with you. I want to have a look here at the gist. Yeah, there was somebody asking. Thanks for helping helping you guys each other. That's fantastic. Can be better. Somebody was asking for the link to the gist. Wonderful that somebody provided it. And as you can see on the Discord server, it shows you the gist. You get like visualizations, etc. So the Discord server is, I would say, 10, if not 100 times better for Q&A, for documentation, for interaction than what GoToWebinar provides us with. For regular questions, that's all good. But if we are in a coding space, that's kind of like different. And my other major reason for emphasizing the Discord server is that even if the session is closed, even if we are not anymore in GoToWebinar, we still have the Discord server where we can exchange ideas, where questions can be asked and can be answered, and so forth. So it's independent of our live session. It's synchronous and asynchronous communication, if you like. Right? All right. Are there currently already questions that you might want to address before we dive into the coding side of things? This was roughly what I was planning for. Here, half an hour to set the stage. I have on the left-hand side, whenever you see me looking to my left-hand side, this is when I check the questions for my Discord application is open. So yeah, the question is here on the Windows machine. Basically, I don't know about your background. It might be that we do stuff where you say, well, okay, this is also simple, no worries, I know what to do. In the other case, when you say, well, this is the first time in my life that I consider doing some programming at all, this might be a little bit more difficult. I said in the email before, if you want to follow along the Docker usage, which I want to do today no cloud, but Docker usage, right? I will do this on the shell here, right? Where you see I have here my iTerm open. It's a shell. Any other terminal emulator would do as well. On Windows these days, you work with PowerShell, even command line. You need to have access to Docker itself. It needs to be installed. If not, if you say, well, I skipped that part, and I can imagine that some will do, then you can work with what we are going to do afterwards. with your local Python installation, but at least you should have installed Python via Miniconda. So when you skip the Docker part and you don't even have Python installed, you should then do the Python installation steps afterwards for Windows, right? You will see when we go to the Miniconda page, probably most of you have done so already. For Anaconda, I prefer Miniconda. Then you will see, well, here's Windows, there's Mac OS, and there's Linux, and then you find your installs, right? So again, I'm always looking here for questions that might pile up. I cannot type, obviously, but you see that I'm answering the questions, and maybe later on several important questions might be typed, or the answers to them might be typed out as well. So assuming that Docker is installed, and you see here on my Mac machine up there is Docker. So I updated Docker just recently, but any version should do, because we are not going to do any fancy stuff with it. I would say it's more or less the most basic things you can imagine. I primarily use Docker now to have a clean slate to come up with an infrastructure out of the blue, where we built the complete infrastructure from scratch. And I'm here in my live folder, as you can see, right? I don't know why this is necessarily conflicted. I need to check that in a second. Let me do here, because I had some updates, you might have seen it, and it's always when you have, like, let's say, an important meeting, right, where important updates come in between, but I don't think that I would need that one, so I can simply delete this was kind of like an overlap only, right? So this should be done now. This is my folder where I have the Bootcamp files, and there are not that many. It's just the Markdown file. It's the Jupyter Notebook. Here. So there's another question, which is a technical one. You cannot compare a Docker container with an IDE like PyCharm. So PyCharm is an editor. A Docker container gives you a complete runtime, meaning a complete operating system, where I'm going to run now Linux from scratch on my Mac machine. So maybe you have a look at the introductory pages on the Docker page. Right? This is something completely different. In other words, you will have your IDEs within a container, on a server, or wherever you're working. Right? So these are two different worlds, if you like. So when I get started with that, so you see I somehow was anticipating the questions with regard to Docker, because people say, well, it works all for me that way, why not sticking to that, and why should I bother about Docker? Just try to get the gist of it to see where there might be benefits, right? So here, this is in the gist at the beginning, and I'm providing you already, if you have Docker installed here, with the line that you can use to start your container, right? Here, to run a Ubuntu-based Docker container, execute on the shell the following. Again, if you say, I skipped that part, no worries, the rest you can follow along without having done so. So I'm now, this is like magic still. After so many years, for me, it's still like magic. I now have a Linux, a Ubuntu operating system on my Mac up and running, and can do the same things that I can do on a remote server, for example, right? So you see here a couple of commands. This here specifies that I want to have an interactive shell. This is a port that I can use. This just gives it the name, PFFBC, so Python for Finance Bootcamp. This mounts a folder, technically. This will give us access to my local machine. Here, the operating system, and that's the application that is to be started. So when you now have a look, here, ls, this is the root folder of the Linux operating system. You see there are a couple of folders, and we shouldn't bother too much with all of these. Most of them are used for technical reasons only. So I will navigate to the root folder. So the sysadmins among you might say, oh, well, he's doing everything here with root, but it's in Docker container, it's locally. So I think we can live with that for the moment, for illustration purposes, I would say anyway. So now I'm in a folder where, like magic, you see here I have the live folder, and this is my local folder, which I've shown you before on my local machine, right? So you see we have 3 files and they are now mounted. This is, if you like, this is like a window out of the container via which I can see a selection which I have specified before on my local machine. So just a few files. I can here, there's one command which is by default, it didn't give me the man. I can use cat, for example, and here in live the 00. For example, I can have a look at this file via cat. Don't worry about this. If you don't know what cat is, catalog, right? Don't worry. But you see, it shows me the contents of my MD file, which you see here in the gist, right? So that's that file. This is nicely rendered, but here you see it as plain text with the markdown commands in there. So the first thing that I would usually do here is to do an update. This is like update on Windows, or check for updates, it's called on Mac OS. It simply gets the latest versions here updated, not in the form of the packages themselves, but in the form of metadata, so the package index, so that the system now knows what is up to date, and it knows anyways where the system stands, and therefore usually you would do an upgrade as well, where say, get me to the latest and greatest versions. Here it asks me whether I want to do so. I say yes. So the Ubuntu image should be pretty new, so not that much of an update. And we are now ready to think about the Python installation, because someone was asking, why not using an IDE? Yeah. Speaking of an IDE, first I would say, well, we would need Python, right, before we can execute some Python code. And when I type Python here, or Python 3, right, you see there is no Python whatsoever, right? So no Python here, clean slate. Therefore, we have the need to install Python if you want to use it, and therefore I up install wget. This is a tiny little helper tool which allows me to retrieve from remote sources files, packages, whatever, right? So apt install wget. And when I now go to the Miniconda page, you see I've bookmarked it here. You find the link in the gist. It will show here, for what I was saying, Windows, Mac OS, Linux, the latest installer. So there might be hardware differences, like here still 64, 32 bits. In the Mac OS world, there are obviously still Intel machines and Apple M1 and M2 these days, right? Here for Linux, you also see certain different options. And down here, you see older installers for 3.8, 9, 10, right? Down here, the Mac OS installers and so forth. So usually, by default, I would say we would go to the latest Miniconda installer link. So if I would be working now on my Mac OS operating system, right, I would choose one of these. I'm here on a Mac Mini M1, so I would choose one of these two, right? I have also an older one over there, my third desk, which is an Intel 64, right? So you need to be careful here. With Windows, I would say there is these days, I would be surprised if somebody is still running machines that require 32 bits. Here, the first one. Here in the world, we need to be more careful. Now that I'm running Linux and M1s are on the AI architecture here, therefore I go with that one. So this might be slightly different for you. So you need to think a little bit, right? Like a decision tree. Operating system now in a Docker container is Linux for me. which is the hardware. Yeah, that's now here the right one for me, ARch. It's not the standard 64-bit x86, right? And now with the link that I have copied, let me retrieve. Here you see that's the link. We didn't see it before, so this was just like with a right click, it said copy link, and this is now the link. And when I execute this line of code, you see it downloads quite a bit here, like 52 max of RAM, not RAM, file size. Doesn't use the RAM up, it's more on the disk side, right, on my SSD. When I now have a look, ls, we see beyond live, we now have Miniconda latest, ls minus an, so we now get the full overview. Here we have the 52 max roughly here for the Miniconda installer. If you download Anaconda, which is the all-in installation, many do so, I know that. When I got started, I did it as well because it's so convenient, but it also messes up quite a bit with your disk and uses a ton of disk space without a reason from my point of view. This might be quite a bit larger. But here we have the Miniconda installer, and there is now in the container not that much more to do than to say bash Miniconda, and I execute. Now you see here that's a sh, that's a bash script, bash Miniconda, right? And now, as usual, you need to agree to certain elements here of the licensing agreement. This is updated every once in a while. I go through it now with the space bar and a couple of things here. At the end of this text, you see this was updated 2022. Do you accept the licensing terms? And I have read them a couple of times. I say yes. And there is now another question that is asked. It's root Miniconda. I'm fine here on my installation on my on the Docker in the Docker container on my Mac OS. I change the path usually to my username Python. In line with everything else there. But Miniconda 3 here, root, this is in line, I would say, from the naming conventions here, perfectly fine with the Linux world, so I can simply press the return key. This works on macOS similar to what you see here, and also works similar on Windows machines. There shouldn't be that much of a difference with regard to the installer. Of course, there are minor difference when you say you want an EXE installer or other types of installers. You saw maybe even for the macOS versions, there have been 2 different ones. But these are minor differences. They are not major, and they shouldn't put you into any trouble. At least I hope so. So run conda init, and I say yes here, please run conda init. That's usually the option that you want to choose. And when I type now Python, it's still not found, Python 3 neither, right? I need here to make this all active, I need to rerun bash, and now you see a major difference here in the prompt. Before it was just saying root at pffbc, now it says base in parentheses, root at pffbc. So conda and list gives me the list of the environments, and by default we just have one environment, that's the base after the initial install. And yeah, you see here the star, the asterisk, it's showing that we are in the base environment. If you would have like 5, 6, 7 environments, we can have even more, right? It would show why the star, and here why the prompt, which Python environment we are. So you have seen before there are installers for Python 3.8, 9, 10, whatnot. But once you have installed one version, you can install other Python versions as well. So saying you have, for example, the Python 3.10 installer doesn't prevent you from using Python 3.6, for example, for whatever reason, right? So that's all possible. When I now type Python, that was one of my goals. You see, I have here Python 3.10 installer, and the version of Python is 3.10.10. So for March 21st, 2023, as we can see here. And for the first time, we can do here our hello world example, and we have executed our first line of code. So without me talking about every single step that long, if you have done this a couple of times, this is a matter of seconds more than of minutes, at least for the base installation. There might be details or certain configurations or whatever, right? It might take a bit more time, but for the base installation, you see, we are already pretty good to go here, right? So when I want to exit here with as a function, right? I'm back on track. Speaking of tools and packages, right? On the command line, what I still like to use, and many others as well, I know that. Maybe it's not as popular as it was in the beginning, but IPython as a command line tool is still pretty good and efficient if you are used to working with it. Here it's not yet there because by default, my default installation doesn't provide us with a installation of IPython, but now the trick is that we can use conda. You have seen me using conda and list here already. Conda install IPython, for example, right? It communicates with the remote server. It shows what it intends to download, and then we say probably yes. Most often I would say, and after the installation, like magic, I now have IPython as a tool. This is not a Python package and not needed to execute Python code, but it's a tool based on which you can do interactive coding on the shell, on the command line, more easily than with a standard Python prompt. For example, when I do my hello world correctly here, you see among others that you get code highlighting here and numbered input as well as output prompts, right? So that's now, what should I say, the starting point. When we think in terms of other packages, for example, we have gone through it. I'm not intending to use it, but thinking in terms of package, we have already a ton of packages that come with a base installation. So math, for example, in finance, of course, important, right? Math, let's say we go with the exponential function here. We get the Euler number, math x. So that's the message, a ton of base standard packages that come with a base installation, but others, this is what I was saying before, like NumPy, that we are going to use quite a bit later, right? They are not necessarily there. So the whole Python ecosystem of packages consists of a pretty small ecosystem at the core, which comes with a Python interpreter, like Python 3.10.10, as you can read above, right? But there are so many others around it. Maybe you can say there is the next ring around that, second level, like NumPy, Pandas, Matplotlib, that need to be installed if you want to use them. And going a little bit further, then you have thousands and thousands of additional packages that can, many of the important ones, most of them can be installed via conda. Some of them need to be installed maybe a bit differently, right? So this is just to show how we go along. We have a ton of things already, but even more tons need to be installed if you want to do what we want to do later. So let me go here. So one more thing now, one more tool, because the tools are agnostic in terms of the packages, right? Whether I use NumPy or not doesn't necessarily define whether I want to use IPython, or to this end, Jupyter Lab. So I want to install now Jupyter Lab as one of the major tools that we are going to use later on as well. So Jupyter Lab, I need to write it here together. So conda install Jupyter Lab. Right. Same procedure. It communicates with the server. I say proceed yes. You see here a bunch of packages are downloaded. The speed, of course, depends on the speed of your internet connection, right? And once this is done, I can start it. Now you might notice that I use here a blank, and this is just the starting point. This might not work properly. Let's see. You see here, at first it looks pretty good, successfully, etc. here, right? Then read the migration plan, Book 7, etc. NB Classic extension was successfully, and then the final message here: root running as root is not recommended. So allow root to bypass. So again, the sysadmins among you might say, oh my goodness, what he's doing. But this is here in a Docker container run on my local machine, so it's not, let's say, more unsafe as compared to running myself a local Jupyter Lab server, right? So allow root here. Now it shows me here with the token certain things, and I want to highlight here at this stage, you might recall, and those of you who have experience with Docker containers, you might recall in particular that we have set the port, the only port that is mapped from the container to the outside world and vice versa is 9999. So by default, it starts here with 8888. So this won't work. You also see here that we have kind of like a lengthy token, which is a security mechanism, and I want to circumvent both problems. So far, it looks good. It's running in the backend, but I couldn't access it. Therefore, let me heal it as follows. So the first thing I'm going to do is to set a password, Jupyter server password. So this will prevent the usage of a token. So here for myself, I use let's say short, unsecure password. And after the verification of the password, if this was correct, right, it writes the hash password to Jupyter server config JSON. That's a configuration file, right? So the next thing is with regard to the port. So I go here up, right, allow root, and now I say port 8888, right? And the IP address, something that I'm going to do as well here. Sorry, I'm in Linux here. I need to set it to all local IP addresses. So, and of course, some of you might have noticed it. I need to set it to the 9999 that I've used before. When you wonder where the 9999 come from, this is here the 9999, right? So therefore, I need to set the 9999 here as I'm doing now, because when I leave it to the default, it wouldn't work for me. So getting back to the shell, right? Jupyter Lab, allow root, port, and the IP address. And now let's see what is happening. So it goes through it. Right, no web browser. This is something that we can ignore. It's now running, right? And instead of some lengthy token that we have been seeing before, it now provides me here with the relatively short address, the port 9999 and lab. And now let me try in my browser whether I can access it. And indeed, under this address, at this address, I now get the login prompt, and here obviously I need now to use the password that I have created before. And after a little while, I'm now here in the browser with my Python installation via miniconda. I have installed IPython, right? I haven't installed any other fancy packages, but I've installed Jupyter Lab with a few parameters, right? I could start it on the command line, right? So For example, when I go to live, I can now use this here and edit, for example, the text when I get back to the command line. If you want to have my startup command, like that one here, I can change the text in the, I'm now using my Docker container Jupyter Lab editor to change my local file, right? So here that was within Docker. So once Jupyter Lab, let me emphasize that as well, is installed, run it with the following command and the options, obviously, right? Jupyter Lab, allow root port 199, IP address, and the comment no browser is something that we can ignore, right? Let me maybe update this now. I can own, this is something that I can only do locally, because this requires security features. And when I now restart it, you see now immediately here in the gist, the change that I've done in the MD file is now reflected in the gist, right? So if you go that way, you install Jupyter Lab, right? And then you can run it. Assuming that you have used these commands, you can then run it via this command with the respective flags and options. Here is a question how to see the steps. Yeah, the steps are of course recorded, and when you go through the video step by step, you can then follow along the single elements. There are just a few, like conda install Jupyter Lab, and then you run the command that I've just copied into the gist file. So maybe several changes here. So what I prefer usually is Jupyter Lab Dark. So for me to have the light theme here, it feels like unusual, right? I usually don't want to have this column to be shown. And we are now here in my live folder, but we need to be careful. If you follow along closely, you can notice here that this is now the Jupyter Lab, which we have started together from the Docker container. And here I have a local Jupyter Lab running on the standard port 8888. Maybe I need to close this in order to avoid any conflicts. Right? So that's where we are. And I can now, let's try. I can now open, that's indeed not, this was the conflicting version, but that's not a big deal, right? We can now get started from scratch here with my 01 PFF Bootcamp IPython notebook. So, and I want to spend maybe just a few minutes so that we have the context again with regard to data types, because this is good to test a couple of things. And when you see me doing, I don't know, inserting here a ton of cells, I am used to navigating on Jupyter Lab with primarily keystrokes, right? Key bindings for shortcuts. But of course here, if you're not that used to yet to Jupyter Lab, you see here like moving, right, and adding cells, etc. So then I've put it here on the right hand side. So I like to use the shortcuts like A, B, C, not C, C is for something else, but there are a ton of shortcuts, right? So data types. You might be aware, and I'm doing this purposefully because I have some applications in mind where we will discuss data types and where we might change things, right? Yeah, and I was pointing it out, but I'm aware of the fact that people are maybe still joining. the session. Somebody asking how important is Docker. I was commenting on that as well. So A, please post your questions on the Discord server. This is where they should be posted. And B, I think working with Docker containers, at least on a basic level, is an important skill today, period. Everybody else doing programming, Python for Finance will confirm that, right? But for the bootcamp, you don't have to go through these steps. If you have Jupyter Lab open and you now want to follow along, that's fine as well. But again, see it as a chance. If you haven't done anything with Docker yet or with Cloud Instance, see it as a chance indeed to get into these technologies, which are so important these days. And not only in Python for Finance, these are skills that are like required in so many other places, circumstances, and use cases. Right? So why data types? Yeah, just to recall what we have something like, oops, I should press here, something like numbers. What is a number here? We would say in mathematics, that's integer, right? And in Python, this is an integer, this is an int, right? Here we would also say maybe that's a natural number, right? So I'm not really here into semantics, right? But in Python, if we want to process data, it's important that we are aware at least of the most important data types that we have, and also later on the structures. What can I do with integers? Yeah, I can do calculations, and since years I use 3 + 4 as my starting point, but I can do multiplication as well, subtraction, and that's of course all possible. I can do more sophisticated stuff like 2 to the power of 8, let's say, or 4 to the power of a half, if you like, right? This gives 2. But we see already here that this operation where I use something that is not an integer suddenly gives me something that is something else, because here we see 3, 7, no dot 0, suddenly it's 2.0, right? So what is that? What is a 2.0? What is a 2.5? That's a, let's have a look, type. So we call type on it. That's a floating point number, right? So floating point number with several decimals, maybe just one, as we see here, or maybe a couple of these, right? They are, of course, important in finance. It's like we cannot get by, if you like, with the integers only, with the natural numbers, let's say, because just think in terms of currencies or in terms of stock prices or option quotes or whatever. They have something like a dot and then several digits afterwards. So we need something that reflects the rational numbers in mathematics or the real numbers. And this is where the floating point numbers come into play. With them, I can do basically the same things like with integers, right? Plus 1.75. So all the basic arithmetic operations that work here as well. Also more sophisticated stuff, if you want to call it that way, 2 to the power of a half, like the square root, right? This works like a charm and out of the box, right? So what we often do, of course, in Python is that we work, as in mathematics, with variables and variable names instead of the numbers directly. So here we just have numbers, be them integers or floating point values, but we often have something like A equals 3, right? And B equals, let's stick to the 2.5, right? Now, when I type in A and execute the cell, I get the value because this variable is pointing to 3. Or, as we say, the equal sign in Python is what is called the assignment operator. So this operation assigns to A the value 3. Or we can say A after this operation points to 3. So pointing or assigning, that's where we are. And let me include a few more cells. And what I can do is also look up the type of A, and it gives me an integer. So this shouldn't come that much of a surprise. If A points to 3, right? 3 is an integer, then the type of A is, if you like, somehow inherited from the number 3. The same, what I was saying before, holds true for B in this case, right? And A times B, for example, works as well. So I can, of course, and I did it up here, right? So I have a floating point value, I have integers plus another floating point. This is all no problem, as it is no problem in mathematics as well, right? So here you see there's a technical difference between a 2 and a 2.5. But mathematically speaking, when we say 2 plus 2.5, we wouldn't even think, at least I wouldn't think, about whether this is technically speaking an integer and float or whatnot, right? So usually we simply take this as given. But every once in a while, when we need to do some conversions, this is something of importance, right? So that's now with the basics and doing calculations using Jupyter Lab here as a calculator is maybe already one benefit. When I do the calculations, I often do it with IPython because on the shell it's a little bit quicker, right? But we can do quite a bit more here. So speaking of data types, what else do we have? We have data types in the form of Boolean values, true, right? Now you might wonder whether we have like a type of that. Yeah, this is bool, right? Type true, and we have the counterpart, which is false, right? False. Let me now do a bunch of these here, right? False. So type of false. It's also bool. So we have these two Boolean values, true or false. Now you might wonder, what do we do with them? Yeah, often, I would say more often than not, the trues and the falses are the results of other operations. I have introduced the assignment operator here, like the equal sign, but we also have comparison operators, right? So when I say something like 4 greater than 3, two numbers that we have been working with, you see the output is a true. So now we get a bool as the output. It's easy, obviously, to now generate the opposite, the false, right? True and false, because 4 is here. You can think, usually I think in terms of the questions. I say in the back of my head, is 4 greater than 3? And we would say yes. Now it was with the second example, we would say yes. That means that this expression, this is true, right? The condition is met. That's true. Or here it's false, right? We have more operators. We have the equal operator is 4 equal 3. That's not true, but 3 obviously is equal to 3. Or we have the greater and smaller equal. Right? We have 4. Let me design an example which somehow makes sense here. Yeah, I mean, I can write it out first here. Greater equal 0 makes sense. 4, right? Greater or equal 0.1. That gives us a false. So you see, of course, I can compare also integers to floating point values, and just to make it somehow complete, smaller equal than 4.9999. No, that's false. Right? So these are the comparison operators which give as an output another data type, base data type, which is bool, which is a true or a false value here. Right? So what else do we have in the data type space? Yeah, we have also string objects. They are kind of a bit more elaborate, if you like. We can do more with strings, right? Here, let's say I get started with Python, right? And you might have noticed, maybe it's your second nature already, I can use double quotes, right? Or I can use single quotes for strings under regular circumstances. Must be just consistent. I'm a big believer, I prefer strongly single quotes for regular strings. I don't know why, I don't know where it's coming from. In other languages, this might not be the case. So now we have here S, which gives me a string. And when we look up the type of S, you know about assignment, etc., right? We get now the string type. And the string type has now a couple of interesting features compared to the others. For example, I can, when I put a dot behind the string and then press the tab key, I get a selection of a number of different, what is called methods. Here they are called functions, right? And this indicates that we can do quite a bunch of things. I don't want to go into the details here, but later on we will make use of certain methods, capabilities that we find here, right? For example, upper is kind of like one that we can easily illustrate. Upper is a method which takes all the characters in a string and transforms them to capitalized letters, right? So that's here the one of the methods. If you now wonder, do we have something like this with regard to integers or floating point values? Yeah, let's check. A was an integer, and indeed we have something like this there as well, right? We have the bit count, for example. It's called bit count. We just need 2 bits to represent the value of A, right? For the B operator, right? So we have there also a bunch of options, right? For example, I can get the hexadecimal representation of the value of B here, right? So methods attached to objects. This is something that you will see all over the Python world, and we will make use of such methods, particularly when we deal with the array object and a data frame object from pandas. So in the first case, NumPy, in the second case, from pandas, right? So, but strings can do a bit more. So this was just the starting point. What might be surprising is that you can do, somehow it looks like numerical arithmetic operations on strings, but it is not. So it's not a mathematical operation here. When I say 2 times S gives me Python plus Python, also I can do S plus S. This works. So this is now also Python. You see the string is simply concatenated to itself. So we have a string with double the length and double the content from before. Okay. So that's here, still find it interesting because it looks like a mathematical operation. And if we wouldn't know that this is a string, we might expect as an output a number, like a value, I don't know, 14. Let's say if S is 7, for example. And one more thing, which we will use also in many different circumstances, is that I can index. By indexing, we always mean here that we use square brackets. So for the method calls, you see we have round parentheses, round brackets, and now I use square brackets. When I go with a 0 index, I get the first character. The second character, shouldn't come as a surprise, is Y. So why 0? Yeah, Python is a 0-based numbering system, which means all the indices and In many other circumstances where we have range objects, for example, we start at 0. Here, the first position in the string is not 1, is not first. So in MATLAB, for example, this would be the case. Here we have a 0, zero-based number. It has a bunch of advantages, but don't want to get too philosophical here. I also can go backwards when I say s minus 1. Have a look, I get the n. This is the, let me go here and show the string. This is the last character in the string, the n here, the last one, right? So I go from 0, here from 0 it's p, I go to the very end. So in the second but last, -2 would give me O, etc. So this works more like a clock than a numbering in the traditional sense, right? So 0 is the first, and then I go to the right, or I can go to the left as well. I can also generate slices like this. When I say 2 to 4, I get th from the middle here. 2 is 0, 1, 2. H is 3, and 4 would be O, but O is excluded. That's another feature of the zero-based numbering system. And this is more or less consistent throughout the Python world. When we later on get into NumPy and Pandas, this is basically the same there. So it's nothing that we learn here about strings, which is specific. The zero-based numbering system and the behavior is something that you learn basically once, and then you would expect it to find in many different places as well. Different packages, that's just by convention, right? So these are the data types, right? So we don't need that much more. So we have integers, we have floating point values, we have the Boolean operators, right? Boolean values, and we have strings. I mean, text and numbers. I mean, this is already a huge world, right? There are, of course, other mathematical constructs like complex numbers or whatever jumps to mind. There is more, but for us, I think for what we are going to do in the bootcamp, that's already a good starting point. And whenever we need something else, we simply add to our tool set a bit more in this context, right? Okay, so let's get to some data structures, which are also so important, at least to the base ones here, data structures. So what are data structures? In a simple case, you could think of a data structure as a collection of more basic data types, or a data structure as a collection of other data structures. So there are some collections of something, right? So far we have worked with single numbers, single floating point values, single Boolean values, but of course in finance and in other domains we are faced with let's say a data set which has 1,000 numbers or 2,000 numbers or maybe 2 billion numbers, right? And this is where data structures come into play, and therefore I like to introduce the strings like at the end of the data types, because here we see already quite a few features of data structures, right? Where we have as a string a collection of single characters put together into a single string. But let's get to the basic structures. And there is like one, for example, which is pretty basic, and you might judge it from the syntax when I say 1, 2.5, and something like Python, for example. So I put it here in a single line, just separated by commas, and I get something back here in the form of parentheses and then my content. So let me copy that line here, and this is basically what is called a tuple. So T now is 1, 2.5, and Python. And when we look up T, the type of T, this is a tuple. And I got started already with a case which might be considered special, that I say I mix up here data types. And if you fancy, I can go with here a Boolean operator as well. So that doesn't make any kind of difference. So in the tuple, we now have an integer, a floating point number, a string object, and a Boolean object. Right? So that's as a starting point, a data structure which allows you to put together for whatever purpose. So we are not talking about purposes in terms of like, why do we need them? How do we use them? What do we use them for? Right? First, we recognize that they are there. Right? So that's a tuple. And with a tuple, I can do a few things. As before, we have maybe some methods. Here you see there are just two methods, not too many, I would say. Right? Two methods, count. Let's say count, for example, this counts the occurrence of certain elements, like count 2.5. Oh, this just happens once. That's an easy case because we just have a few elements. Or I would say count, how often do we find the number 3 in the tuple? 0 times. So that's about counting. The other method would give you the index position of an element that you're looking for. Let me try something else, like 2 times t. This works like before. It's not a mathematical multiplication in that sense. When I say 2 times t, it gives me another tuple where I have the content of t presented twice. So before, like 4 elements, now 8 elements. With the elements simply double concatenated one version to the other. When I would do the other thing, t plus t gives me the same thing. Now, I mean, I haven't illustrated this. What I usually cannot do is something like this might jump to mind, right? Maybe we would like to try something like 2 over t instead of multiplication. We get an error. Or we might be as fancy and say t over 2. This does not work, right? So it's not that we see here multiplication, quote unquote, and addition. No, that doesn't imply that we have the other operations there as well. Not necessarily. In other circumstances, we will see that as well. Right? So now something else, a list object. Right? And this is something for the case study that I planned for today, which will be about real-world financial data and kind of like a larger data set. We will work intensively with a list object, and we see that, depending on how you approach the problems, might be pretty involved. If you know a couple of tricks, it might not be that involved. But we will see when we do the same little case study with NumPy and pandas, things change considerably. But first things first, a list object. So I can generate a list object in the same way. Right? Python. Now I have a list object. Oh, I'm sorry. I don't have a list object. So I was lying. I don't have a list object because I forgot something of importance, namely to use square brackets. For list objects, I need square brackets. Now you see it changes to the square brackets, and suddenly L becomes a list object. So up here, where do we go? So this construction could have been done also with the parentheses up front. So I can put them in here as well. So type T tuple would stay the same. So these two ways are equivalent, right? So here the brackets, I forgot them, so I ended up with a tuple, was not intended, needed to add the brackets. So I haven't emphasized it, but now that we have a list object, I can make a direct comparison. In the case of the tuple, I added in the line where I generated, where I created the tuple, I added false at the end, right? Here, when we have a look at it, right, this is where we came from, I can use, that's one major difference, but it's a pretty important difference, I would say. I can append, let's say, true to my list object, right? So in other words, now speaking technically, list objects are immutable, so we can change them when they exist. We can change them, we can add elements, we can drop elements, whatever, right? And here the tuple objects, here tuple objects are immutable. So this has the effect that I said before. I mean, once I've constructed it, it is as it is. So I cannot later on add something to it. So I would need to recreate the whole thing from scratch, if you like. This here was created and I can add it. So think of a list object like a backpack. It can be a small, tiny backpack, can be a large backpack. And whatever you want to put into that backpack, you will find space. I mean, the space is limited obviously by your machine and your working memory, right? But in theory, you can simply add to the backpack because it is flexible, stretchable in an unlimited manner, right? And what I was saying before, I can also, when we look it up now, here I have a bunch of methods on top of that, where I can remove, where I can pop. Sorting is something that I can do. It's currently not that interesting, right? But pop, for example, is something that is often used where I can, for example, pop, and now I need to work with also one hint. When you are not sure what to use, what to pass, what the arguments are, you can always put a question mark behind a method like this. And then you see remove and return item at index. Default is the last. Raises index error if list is empty or index is out of range. Right. So I'll leave this here maybe as a marker that you see it later. So pop, if I want to remove and return the first element, I will need to put the 0 in here, and it gives me the 1. And you will notice when you work with list objects, basically everything you do is permanent, right? I've executed this twice, so I end up with 2 truths here. I pop the 1, and I end up here with the new list object where the 1 is missing. When I now would repeat the exercise, I would get rid of the 2.2. So we need to be careful. These methods, they have a permanent effect. They don't return, like with NumPy and pandas, it's often the case, let's say, temporary views on something. So maybe let me save this and rerun the whole Jupyter Notebook. So restart kernel and clear all outputs so that we have a execution one after the other, right? And now run, where do we have it? Usually I have this as here, run all cells. Usually I have it as a shortcut, but not in my Docker container yet. So that's now the state that we end up with when we execute every line in sequence and just once. And again, the list objects with their functionality, they are something that I want to make use of a bit more intensively when we attack a real-world financial use case with a pretty or relatively large data set. Right? So these are now two important data structures. There are more, just maybe a very quick view on dictionaries. So what we are going to do, dictionaries, I have nothing in mind where we will make heavy use of them, but just to have this type of data structure as well. So a dictionary, the usual analogy is like a telephone book, right? Where you have a name and a telephone number, and the names are in alphabetical order, last name alphabetically, and then the first name alphabetically, and then you find the telephone number. In the days where we are living in, that's not that popular anymore, but people as old as me, they will still remember like the thick telephone books. And when it was starting back in the days more than 20 years ago to travel to New York, and depending on the hotel, you had like a number of thick telephone books. I don't know who went through them, but the message here is a dictionary is like a telephone book in that you have something like a name, let's say here A, for example, and then you have a number, let's say 10, and then you have another name like B. Here I do it in alphabetical order, there wouldn't be a need for that, and we have a value 25. So in the telephone book analogy, this would be the first name, that would be the number, this would be the second name, that would be a number. And the idea is for that data structure that the lookup via the name is the intended purpose. So it should be as easy as it can get to pass a name, to look up a name in the phone book and to get the number. The other way around usually is not optimized, is neglected, shouldn't be that important for the use case. And I think that's clear. If you have I don't know 5,000 pages for 5 telephone books, let's say, and you only know the number, we can all imagine that's pretty difficult to find out the name which belongs to that number, right? So, and that's here the case as well. So one way should be easy, the other way is difficult. And for those of you who are maybe in crypto and work with hash functions, that's more or less the same idea, right? Hashing is kind of easy one way and should be theoretically or practically impossible the other way. That's what dictionaries are, at least to some extent, about. So the now we see with the curly brackets and the names and the numbers. And for example, if I'm interested in the value for B, I put it in brackets and I have something like the indexing from before, but now I can work here with the strings. This could also be a number. They are pretty flexible. So again, I don't want to spend too much time here on the dictionaries, but just that we have this basic and fundamental, we can even say, data structure as well. And of course, the question again, this is all recorded and we will put it latest tomorrow on the Quant platform, where you see the recording then presented on the dashboard and you can dive and dig deeper. All right, so let me maybe wrap up here before we move on, and let me restart and clear all the outputs. So let me save it. I need to get local here and do the update. So I'm now pushing it to the gist. Now for the first time, maybe we can say we have something here in the gist. So I'm reloading the page. And you see everything that I was typing live. Maybe some of you have been following along line by line. For those of you who haven't, you now have in the gist here the complete documentation of what we have been going through, right? And you can execute it here. There's nothing special. This should be executable on any machine where you have Python installed plus Jupyter Lab. You should be able to open this and to go through it step by step. Yeah, that should be a good point. Now to maybe here I move this a little bit. This is what I was working with from the Docker container, so that I always know when we go, when I'm going to use any package that might not be installed by default, that I'm always aware of what needs to be installed, and I can share the single steps there, right? So here, with regards to Python, we have built the infrastructure, we have dealt with tools, idioms, not that much. Data control is something that I want, and idioms is something that goes through the whole set. This is more like syntax in the English language, let's say. Data and control structures is something that I want to cover in the second part, but I think now is a good point to have a 10-minute break so that you can get some refreshments, maybe drink something, get a coffee. Maybe also, I haven't noticed that, download the gist. So here in the upper right-hand corner, there's a download zip. Or for those of you who use Git, you simply can do git clone, and you can clone the whole gist here, right, on the command line. But if you're not using Git regularly, so well, downloading as a zip and unzipping, it's preferable. You can do this here as well, just by clicking on download zip. But if there are no other questions, just let me check here. No, this looks kind of good here in the other places that I'm checking. Then let's go for a 10-minute break. So it's 34, let's say 45 my time. We will continue with the second part, and then we apply what we have learned to financial data and add a little bit of visualization to the whole story as well. Okay, see you back in now 10 minutes. So, yeah, let's turn to the second part of today's session. I hope you got a coffee. I got mine in the meantime. And we have, as I was saying, covered now infrastructure tools, a few idioms maybe, right? Object-oriented programming, methods, etc. Data types, data structures. Control is something that I want to add, so that we have the tools together to work with what I was saying before, the data set, a bit of a larger data set. Just like the very basics of control, control structures, here I again execute it all, right? So restart kernel, run it all. Sometimes I'm so used to my shortcuts, I should have better instituted them. So restart and run them all, at least this works. And for the control structures, I'm going to add in here a bunch of cells, though we don't need them. I want to introduce one object which has nothing to do primarily with control structures, which is used quite often in the context of control structure. That's the range object. So here you see the output. It's range 0 to 10. You recall zero-based numbering. Start at 0, last value might be excluded. And first glimpse what we get here is when I do list range 10. Right, we get then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No 10. So I got the foot on the brake early enough. You see 10 numbers, but not 1 to 10, but rather 0 to 9. And that's kind of typical. I can do the same here with a tuple as well, for example. Right. We know two data structures, different aspects with regard to what they can do, what they can't do, right? And yeah, range is used for things like, and now we get to the first control structure, like for traditionally I, for example, in range 10, right? And I can now do something like print I. Oh, and we get 10 numbers, or I can do some fancy calculations here, like I to the power of 2, right? And we get here the powers from 4 to 0 value up to the 9 value. So this is where we use range. But we can also do something with this for idiom, all right? Something like this, for S, or let me say rather C, in S, print C, we can iterate over the string object as well, and we get one character after the other. What we can also do, we have our list object, or let me go with a tuple, right? And here I might say for element in T, right, 1, 2.5, Python 4. So we can go over numbers, we can iterate over strings, we can iterate here over a tuple, can print it out or do some calculation or do whatever. So the for loop is a pretty important control structure. Control structures, but for the time being and for what we are going to use afterwards, we can get by pretty well with the for control structure. There is also a use case, and this is where I would say one of the strengths or the flexibilities, capabilities of list objects come into play, where we do maybe something like this. Let's say we get started here, and now I'm going to, or let me maybe write it out this time. Usually I'm a big fan when I do illustrations like these of pretty short variable names for the sake of for the sake of conciseness, right? But here now let's say that we have a list object which we call square, which is an empty list object. Again, the analogy with the backpack should be clear. If we have an empty backpack, it's empty. If we put in one element, second element, third element, we are filling it up with all the flexibility that we have learned about, one element after the other. And this is what I want to do now. So for my number, for example, in range, and I can get started, let's say here 10 and go to 20, you might know by now how this works, starting at 10, 20 excluded, so 10, 11, etc. until 19. Right, so print number just for us as a reference check. So 10 until 19, but this is not what I want to do. What I rather want to do is squares append, and now I want to take number and the square, let's say. So I iterate over 10 values. Of course, this is here all constructed out of the blue. And after the loop, I have now a list object where we find 10 squared values. So from 10, it's 100, 11, 121, 12, 144, and 19 is 361. So that's also a use case of such a for loop. And there are a gazillion of more use cases. So you can imagine that for loop is found in so many different places in the Python world. You cannot give an exhaustive use case list, but these are some basic construct scenarios, right, where it makes sense. So why am I doing it here? Because in this case now, I want to show you a shorthand, which I'm a big fan of. It's what is called a list comprehension. It's not as flexible as our regular for loop, but in many cases it's more concise, and I would think it's more easy to read. So for example, here I can say something like I for I in range 10. So let's get back to the basic case. This gives me a list object, right, with the values. Or when I copy this, here the square gives me now a list object with the squares. This here is equivalent to list range 10. So that's equivalent, right? But something like this, taking a value and then calculating the square, adding it to a list object, requires a for loop, like we are doing it here. It could be done that way, right? So exactly that way. We have done so here, right? This is now equivalent. But you see here we have 2 lines, at least 3 lines for the instantiation, then for the for loop, then for the operation. And down here, right, we are then with a single line at the goal already, right? And that's what is called a list comprehension. So I want to show you something else now. And when I do this, instead of the square brackets with the round parentheses, so I need to get rid of this because it's not true anymore. I squared for I in range, and this is now in round brackets. This gives a generator object. What is that? Yeah, you have seen here when I get started, range, here we go, range 0, 10. This didn't give us the values from 0 to 10. So I needed to call list or tuple on it to see the values themselves, or I needed to iterate over it. And this is not basically, from a technical point of view, the same thing, but just my, if you like, custom tailored object like G, and I can again do list G, and I get now the values 0, 1. Or I need to repeat this. Don't get me wrong, when I now first I show you the effect, otherwise it might not make sense. Tuple G, when I want to use G for the second time, it is basically empty. So when I was iterating over this generator object once, it's empty the way I'm doing it here. So I would need to regenerate or recreate, reinstantiate the generator in order to use it with the tuple. And I can also use now for in a regular way, right? Where I say for a third time, you see, I need to do it 3 times now. G, I can also do for G, for I in G, print I, and maybe end, not a new line. I can specify and print that it just uses a blank and not a new line, right? So these are all nice features that we can make use of in many different circumstances. And now I think that's enough. We have the tool sets together so that we can focus for the final part of today's session on making use of what we're seeing and maybe adding some twists here and there to the story, right? So having said that, let me maybe clean this up, saving it, restarting, clear all outputs, saving it again, and I'm going to push it to the gist so that you have the latest version for your reference, right? And yeah, in the gist, just a quick check that we have it. It's loading. Yeah, the longer the Jupyter notebooks become, the longer it takes for refreshing here to gist page. Yeah, this looks good. We have it all together, right? So here we go. Maybe I should have said this before. This is a generator object. Let me write one comment here: to be iterated over, right? So this is something where you need to do something with it in order to make use of the results of the calculation. Here the list gives us a list. Here another step, if you like, is required. I will later on update it so that you have that as well. So let me duplicate the notebook here and rename it to Bootcamp 02. Right, and let me open this. I need that launcher. And I want to get started here from a clean slate. Quite a bit what we have been typing already together. So if I want to save future work, I do now the duplication when it's empty, right? So that I have the empty version later on available as the third one when we move towards the third one. So now our use case, financial data. Yeah, and I have financial data stored. Basically, different data sets are stored on our servers. And I commented on that with regard to reproducibility, that everything that we are going to do will be based on fixed data set that you can retrieve, where everybody has the same data set, no issues with credentials, API availability, changing of APIs in the future or whatnot. Therefore, here first the URL, that's the most important thing, and maybe I will push that then to the server as well, so that you have the exact URL, https certificate tpq.io. This is where all the resources lie, EOD CSV. Or do we have, let me just think of it, do we have thin data CSV? Let me check before I push it. Let me check, because you see I have so many. EOD works in any case, MLFin work in any case, but I think that might be, is that the latest one? I'm not sure. Let me check. I mean, it's relatively easy to check, and I will do so by using the following module. So import requests. That's a standard Python package. And with that package, if there is indeed a data file, which we will see in a second, I can use requests get, and then I pass an URL. Yeah, and there seems to be a data file because the response is 200, which means the HTML request was successful. That's not returning, to put it the other way around, it's not returning an error message, right? So I can now do the following. I can get some raw object here. So I need to repeat this. So it's like, right, when you call something and you don't make anything with it, you might do it again in order to enter with it. So when I now look up raw, this is the response, but raw dot now gives us a couple of things: connection, content, history, links, okay, raw, request. Maybe we have a look at raw, for example. Yeah, that's still not that meaningful, right? We need to look further. And what I'm looking for comes a little bit further down, and it is the text here. So raw text, because if this is indeed a comma separated value file, this is nothing else than a text file, right? A text file. So let's see if it is a text file. And indeed, you see here the beginning of the text file which has date, Apple, Microsoft, Intel. Then if you pay careful attention here, you have the line break. Then there is a date, 1st of January 2013, etc. pp. Before I move on, I'm going to push this to the server so that you can, if you weren't able to follow along with the URL, so that you have the URL available on the server as in the second notebook here. Right now, you see in the gist, you see the URL of this data file. Right, so we haven't done anything with it yet. I just wanted to make sure that that's the right URL, that you can access it as well. So raw text, again, we can have a look. Here the text, and this is going, you see here the scroll bar, this is going on for ages on end, right? So long. Let me go to the very end here. I need to be slow, right? And 1st of January 2013, and here you see the 30th of December 2022. So roughly 10 years worth of data. Again, I want to go to the oh my goodness, I need to catch this here. When I go up there, it's a pretty long data file, 10 years worth of end of day data. And we would expect here data, price data for the Apple stock, Microsoft, Intel, Amazon, Goldman Sachs, S&P 500, VIX volatility index, SPY ETF, Euro US dollar cross, gold quote, GDX and GLD ETFs. So that's the data in there. And maybe just for us as reference, I show here the first 1,000 characters. So we have worked with strings, we have learned about data structures, we have learned about control structures, and now with this use case, namely being faced with comma separated value financial data, I want to make use of the elements that we have learned about before, right? So that's kind of like the starting point for us. But I mean, it's clear this is just one string. This is like, you know, when you get the data in like a newspaper page and you have it like one character after the other. That's probably not the best format for us to process it, right? So here, if we want to make out of the text financial data, we need to do a bit more. So the bit more now might work as follows. We have raw text, right? We can say, for example, that we have the that we put this into a list object. Let me call it list, right? This is now the first step. And how do we do this? I take raw text, right? This would now be simply the text, nothing happens. And you might recall the split method that I briefly highlighted before. And when I apply the split method here, it gives me, and it's immediately better to read, right? It gives me now a list object where we have every line, if you like, here, where you see the new line and a couple of more of them in there. We see it now line by line. To be honest, I could have done this in the way here as well. Let us say raw text, or let me use that one. And I call print on it. Print on the first 1,000. We get this then also line by line, because this is here what the new line operator does. Here, new line, it's a return, right? It gives us a return. It simply gives a new line. And in this representation, we also see that for certain dates, like 1st of January 2013, we don't have data for every instrument, just for 2 of them here, right? So the data, in other words, is incomplete. We need to be careful here. When I do the split, I would say it's better than printing, because I now have the data as separated lines, single strings in a list object. And with a list object, I can index, I can do other stuff, right? So I haven't done that much indexing with the list objects, but this works like with the string objects that we have worked with. So this is a very important step. And now we go the next important step here. So that's pretty long. Just going with the maybe first, let's say 6 rows. So you see indexing, first 6 rows. This is the same as 0 to 6. I can leave out the 0. Gives me the first 6 rows. In a second step, I'm still here with the strings. Let me now do the following. Right? Let me do S, and I want to do now my list comprehension from before. So what do I do now with the list comprehension? You might recall we have something, we can do with it something for a row here, for example, in my other object. So that would now be here the row for every row in L. This gives me, if you like, a perfect copy of it. So that's not interesting, right? For sure not. So let me go with a 6. That's not interesting. But for the second time now, I work with the split operator. Let me see what happens. I now have just here brackets around my single string. This is not what I want. So I need to specify the character at which the split shall happen. Now have a careful look. Now we get a list object which contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 single strings, and we got rid of all the comma values that we see here in between, right? So now every single data point is separated. We are not dealing with numbers, for example, right? So therefore, the discussion with regard to data types, we are dealing here with strings only. So we have a list object which contains a number of other list objects, basically a few thousand of them. We will see later. I can check that. Maybe 6 here is even a bit too many. Maybe I just go with 3. It should be good enough, right? And the length of S, this is 2,600. I haven't used S yet, length yet, but length can be called on any iterable. So for the tuple, it would have given us maybe 4 or 10, depending on the tuple we have been working with. And here we now seeing that we have 2,600 lines, 10 lines, right? The first is with the headers, and the rest here you see is data. It's to a large extent here, it's incomplete data, right? So here are empty strings, meaning there was nothing, there was no data point. And yeah, that's now the state. In finance, usually we would like to have numbers as numbers and dates as dates. So we are a few steps closer, but we are not yet the data, right? So this this is now our next task, right? That we transform the values, right? So maybe let's hear. Here where we got print raw text, right? So processing the data, giving it a little bit of structure, right? This is just the data that we retrieved and I printed out. Nothing has happened beyond that. And here's where we we could also say pre-process, but nobody knows what we are going to do after the pre-processing. Therefore, let's call it processing the data. And yeah, now in the next step, we would like to maybe collect a subsection. Just imagine you want to figure out what is the average, what is the average quote for the euro US dollar cross. Here you see one, right? This is one for which we have all the data. You see we have the date, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's now do some recalculation, some processing. What was the average FX cross quote over the 10 years? So I said 9, right? I can iterate now. Let's say I go with the euro US dollar and I do the following. I say now again, take every row, but only now the 9th index value for row in S. This is my string version of the data, right? So what is euro US dollar now? Euro US dollar now has the header, right? Has the header, and here, right, all the quotes. But the quotes are, as you can easily see, they are still strings. Whenever we see the single quotes, double quotes, this is all about strings. With the euro US dollar here as a header, I cannot do that much, so I might probably get started here with the second row, the first index value. Right here, one is missing. So this is now without the header row. So the first 5 might be enough for us. There is a question. I mean, the one is how long it took to become a PFF Jedi. Years on end, I can tell you. The second one is related to what we do here. Why doesn't the split with a comma put every single item in the CSV into its own list? Yeah, because it's not its own list. The split operation, right? If you have something like this here, if you have, let's say, 100, 200, 300, 400, let's say, the split operation gives you a list object from the operation applied to your string. So here, split on this gives me just a list object with the original one, right? And the original string, I mean, when I now specify the delimiter, you see that I get here now a list object with the 4 elements, which result from splitting at the comma, right? So that's the reason why it behaves as it behaves there, right? So getting back to our example, where we now want to calculate the average quote for euro US dollar over the 10 years that we cover, we have now the values together, right? But we cannot do a calculation yet. So we would probably want to do something like this, euro US dollar. And this step could be included up here. So, but I do it now in 2 steps. So I overwrite my object and I say float. I transform the string object, right? Element or price or quote or whatever for Q in euro US dollar. This overrides the original object, but we have the effect afterwards that we get now a list object with floating point numbers. And this is something on which the circle is closing, which we can implement our calculations, or where we can do addition, subtraction, multiplication, taking the powers, whatever we want to do, right? So now that I have this object, I'm basically only one step away or two calculations away. The one is, and this is a standard Python operation, whenever I have a collection, as it's also called here, collection of numbers, I can, or some other things on which addition is defined, I can calculate the euro-US dollar sum here as a first step, right, over all the 2,609 elements, right, and then I divide by the length of euro-US dollar, and this is how the mean, this is the average quote is defined. So you see with this bulk of, right, it's just a string, not necessarily text, but a string, technically speaking. We did first the separation into the lines, second the separation into the single elements, third we collected the relevant values from one column only. In the next step, we transformed the strings into numbers, and once we got the numbers, we can do calculations such as taking the sum and dividing by the length of this object to arrive at the average quote, right? So this could have been done for the others as well. I got started here with the euro-US dollar because this is one of the two in this data set, and I know this data set, I can tell, in this data set, which is complete, where the column is complete. For example, let's say we have seen it on the 1st of January 2013, there was a quote for euro-US dollar, but there was no quote, let's say, for the Apple stock, right? So speaking of Apple stock, let's now say that we want to do a visualization. So this was a calculation. So we basically ignored, if you like, the dates that are in the first one, right? So now here collecting, let's say, the Apple stock data, but in like more or less complete fashion. By complete, I mean dates plus the quotes, right? So here, where did we do it? Calculating the average euro-US dollar. Cool. Few lines, and we are good to go. Now calculating Apple stock, collecting Apple stock data, and then in the next step, I want to visualize the price data. So the first thing is, and we have learned about this already here, the approach would be similar to that one. If we are now interested in the dates, we simply need to collect the first elements for every row. All right, so here the dates would be row, the first element for row in S. Right. So dates, maybe 5, date 1st of January, 2nd of January, 3rd, 4th of January. Yeah, that's I would say as expected. Probably we don't need, we wouldn't like to have the date here. So I would start here from the first one to get rid of the header of that column, because we now know that we are ending up here with the dates only. So this gives us now a list object where we have all the dates from the 2,609 rows, it must be in the end, are in there, right? So let's get started. So we we would need to be a bit more careful afterwards. So, but I want to get started with it. So the next thing would be Apple, right? So AAPL is the symbol. Now, not that difficult here. The code can basically be copied. So I can copy this. It's not the first element, it is the second element for every row. Apple. So you see now already a problem, or at least a problem on the horizon. We have a ton of values, and you might wonder, yeah, why if is there Apple stock quote 19.6081946? Yeah, this is due to stock splits, right? This is adjusted, these are adjusted close values, and whenever there's a stock split, they are adjusted backwards, divided by 10, divided by 20, or whatever. This is where we end up with these weird looking quotes that you will never see at the exchange directly, but these are calculated resulting numbers after the stock splits. So, but we have still these values here, right? So not the number values. And when I, for example, now want to do, I just show it and then I redo the whole exercise. Float of row 1, when I want to transform this to float values, you see that I get basically for the very first element, I get already an error, a value error, so could not convert string to float. So if you want to end up just with the Apple stock quotes, etc., and not string objects, right? Then we need to go down a different path. So Apple here and maybe the first 5. So the path, how can it look? How should it look? I repeat for the 2 of them. So these were 2 selections, if you like. I repeat them here. So dates, row 0 for row in. But now I want to condition this on the following. If a row now of 1, this is the Apple stock price, it's not equal, I think I haven't introduced not equal, it's the opposite of equal, when I say not equal, but it's exclamation mark, equal sign, it's not equal empty string. Only those dates, and let me execute this, shall be collected. And now we see here, we have the 2nd of January, where we get started with. And before, here we had the 1st of January, where we get started with, right? So that's the difference now. I make sure that I only get the dates for those rows for which we have Apple stock prices. And this condition is now something that I copy here as well for the collection of the Apple stock prices, so that after the adding of the condition, we end up with a list object for the Apple stock prices where we have no empty strings at all, right? And I showed you already that I can do the transformation. We can do it in the same step or in the next step, right? So let me do AAPL, right? I can now go and say float of the price for price in AAPL. So you see, I again override here the Apple object, AAPL object, and with this operation, when we have a look, we now have, as we had it before with the euro US dollar, we now have just floating point numbers. And I mean, if you fancy, you can now do the same as before, like the sum of Apple over the length of Apple gives us the average stock price. If this is of any relevance, I don't know, but I just wanted to show you here that we can now do numerical calculations. Not dealing with strings anymore. We've changed the string data type to the floating point data type. With the floating point numbers, we can do addition, we can do division, etc. pp. But this was not our primary goal. I said we would like to visualize the data, right? So visualization is something that we haven't done so far. And the workhorse, you know it probably, for visualization in Python is matplotlib, but we haven't installed so far matplotlib, right? I can do it here from the command line, right? I can go and say conda. I think this should work. I'm not 100% on IPython. It works. Install matplotlib -y is what I put behind it. Well, it seems to work here as well. So I hardly ever do it that way. I do it usually on the shell. And here it's now communicating with the server. We have seen this, showing us what it is going to install and how large these packages are. And there's a ton of output now, which is basically not really of interest to us, right? The only thing of interest to us is that the package is installed afterwards. So, right, a visualization of the data. So we should have it installed now. So I leave it here as a hint, as a reminder, but I've commented it out. So what do I do typically for the visualization? I know you find it in many places. Yeah, avoid the pylab import, but I don't do from pylab import something or star. I do the something thing. So from pylab import plt. So this is much shorter than import matplotlib, pyplot as plt from my point of view, but I'm not messing up here with the namespace whatsoever. So now we should be able to do some plotting. Who knows, right? Installing a package, working in the browser from a Docker container in Jupyter Lab. Question is, does it work? So let's see. So the first thing, we could try something like plt plot, and let me try range 10, for example, right? Indeed, at least the plotting functionality works. What do we see here? We know that range 10 gives us values from 0 to 9. And this is obviously what happens here. We get values from 0 to 9 plotted as a starting point. We also see that we get here a technical output, which is usually not of interest to us, right? So I can put a semicolon to silence the output from matplotlib, right? So that's kind of the easy task, right? It's not the nicest thing here in the world, but at least it's our first plot. But we have maybe some interesting data to plot, and this could be euro, yes, dollar, and Apple, maybe, right? So PLT plot. Let's get started with euro, US dollar. This was floating point numbers in the end, and we see here the same technical output, semicolon silences it, and we see now the 2,500 or 2,600 euro US dollar quotes over the 10 years. So the 10 years is only something that we have as background knowledge. I don't see anything with regard to years yet here, but we want to get started at some place, right? And another place to move on might be PLT plot Apple. We have Apple stock prices, putting a semicolon, and we get the Apple stock price. So as a long only investor, I think we all agree we would rather be long Apple than euro US dollar, but this is also, I mean, it's usually not the idea to be long for ages, the euro US dollar. So that's now a starting point. The plots are not looking that nice, right? But we can make them a bit nicer. So I want to get back to, or I can do it further down here so that we see all the results. So I can now use the following style, and there have been changes recently, and I don't like them, to be honest. Seaborn, so this is what I've been using, and so many others for years. Basically, I'm not sure if all my books, but all the more recent books of the 6, I wouldn't bet on it, but more of them have used the Seaborn style here, right? And it's now saying matplotlib deprecation warning. Seaborn styles shipped by matplotlib are deprecated, etc. Alternatively, use the Seaborn API instead. Or here we can use this configuration. But in all my books and in many other places, you will find exactly that one here. But in order to silence this warning, you would need to use these days Seaborn -v 0_8. So that's here, so that's old, right? Legacy version, new version. Maybe you say, well, I don't like that plotting style at all. That's fine. That's fine. What do I do here? Module has no address. USD. Oh, use. It's not USD. Of course, it's use. Maybe you say I don't like that. That's fine with me. But now see, I take the exact same code for the Apple stock price here, copy it down here, and like magic, we now have nice grid. We have also a light gray background and the different color map. The differences here, this stage might not be that significant, but if you add more stuff to it, etc., it might make a difference. I also want to do something else here when I'm not interested in saving these figures for later use, let's say in a book or PDF. I would also configure the inline backend figure format to SVG, scalable vector graphics, because depending on how much I zoom in or zoom out, I'm here with a bitmap, and this might be blurry or whatever. So with the SVG, now let me again copy this so that we have a direct comparison. When I now with the SVG, you might see this is now much sharper, even with me without having classes wearing on my 4K screen. You see this is absolutely sharp. While the bitmap, I don't know if this is given the all the changes and transformations that are happening from generating, displaying it, and then transferring it via the web. If this is really clear here, but this is absolutely sharp for me, and this is blurry. And I think this doesn't have to do anything with me not wearing glasses. If I would wear glasses, the effect will be the same, but maybe both, will be sharper. Right. So here, right, when I repeat this here, it gives me now the SVG output. This is nothing that you would usually use when you save it as a PNG for use on a web page or JPEG or whatever. But here I prefer these days throughout the SVG format. So that's already kind of an improvement, at least for me. I feel now more like home. What we are missing now are the dates, right? In a typical chart, in a price chart like this, we would like to have the dates here on the x-axis, right? This is what we would like to have. So let's give it a try. So for example, just to show you PLT plot, I can go, for example, with range 10 to 20, and then range 20 to 30, just to have an illustration of my point. Before I was just passing y values, now I'm passing x and y values. And we see here that the x values are 10 to 19 here, and here 20 to 29, right? If we want to have it maybe a bit nicer, you might argue we put a 21 and a 31 here for the chart, so that we start at 20, going to 30, starting at 10 and going to 20. So we have now x and y values. Translating this to the financial time series, to the price series, we would like to have as the x values the dates, and as the y values, as before, the prices, right? So let's simply give it a try. So PLT plot, and we now have the dates as the candidates. We have collected them, and let's say Apple stock price data semicolon. So this is now taking long, and I know already why, because my dates are, I give it a few more seconds, my dates are string objects. So it has now tried to put all the 2,500 plus strings as the x values. I mean, we can imagine 2,500 on such a short or such a small place. That's kind of a difficult thing, right? So we need to translate our dates into date time objects. And how does this work? Okay, I want to make a simple example. Let's say we have a date right here, right? Maybe I give this working with, I call it dates, not technically. So date. Let's say we have a date like, maybe this is one of the examples. Let's stick to the first one in the data set, or maybe the last one in the data set, 12/30. This was, I guess, the last one, right? So let me do this as a raw. So this is now a date, and 2,500 of these, that's quite a bit to be put into such a small plot here. So we have now a package in Python which is called date time, right? And with that we can do transformation. So and we can also do other stuff like date time now. This gives us the system time, for example. Right? It's you see it here down to the microsecond level and even further, right? But we want to use this module now to transform this string into such an object, right? Into really a time, a date, and or a time or a date time. All three options are there from the Python point of view. And I promise you this will make the plot much nicer. So date time from no, I hardly ever do this. Here we go. Here strp time. I want to now look it up. String and the format. So new date time parsed from a string, and this is basically our use case. We have a string here, and we want to parse the string in order to come up with a, again, technically speaking, a date time object, which represents a date and or time and or date time, right? So string and format. So with regard to the formats, I only recall in general the very basic ones. They are as follows. So first is the string that I pass. That's the date. Right here it says a type error, takes exactly 2 arguments, 1 given. From my point of view, it's lacking intelligence, so it could be a bit more intelligent because this is a standard format. But nevertheless, so I now provide the format, and this is done via percentage values. So year and then percentage month, and then percentage day, right? I think there's, well, I'm pretty sure there's one thing missing. So this is saying a value error, time data does not match the format. And I know why, because lowercase y is only for 2-digit years. I need to have an uppercase y to indicate that we are dealing with 4 digits for the year. And now we get the datetime object, 20, 22, 12, 30, 0, 0. We don't have time, so hour and minutes are 0, but we now have, like here, the datetime. Of course, datetime now changes every, yeah, I mean, you get the point. That's simply the system time that we see here. And in this way, I can, from a string, by providing the format of the string, I can create such objects. So going one step further, I have a ton of dates in my dates object, and I can transform them as follows: dates. Now I apply the very same thing here. It's pretty long, right? Here, I put it in here. I can also go to the next line for date in date. So I'm overwriting it again. So we need to be careful. In interactive formats, I often do that. For production code, it's probably not best way to do. I think the intention is clear. I want to do what I've been doing once here. I want to do for all the 2,500 plus dates that we got. I want to know, check 5. We now have datetime objects, 2nd of January, 3rd of January, etc. Now let's see what the plotting does here. The plotting was much faster, and like magic, matplotlib has quite a bit of intelligence built in to deal with the datetime object. And to see now we have on the x-axis we have the years. So it even recognizes, oh, there is a lot of information with regard to every single date, but for like visualization purposes, it is enough to show here just the years. That's, I guess, a pretty nice feature. We can, of course, if you want to get a little bit more closer, I copied this now. You could repeat this and say, show me the final 100, for example, indexing, right? And here, this must be in line, the final 100, otherwise it wouldn't work out. So, final 100. And then we get here like months displayed, right? This is the final 100 days, final 100 values that we have there, both on the date side as well as on the Apple stock price side, right? Maybe some other plots, right? The frequency distribution. We can also use PLT histogram, which is the technical term for frequency distribution, and I can pass in here Apple, or let's get started maybe with the euro US dollar. Do it for the 2 of them, semicolon. And this is pretty coarse here. You see, it's it doesn't say that much, but we can use one major parameter, that's the bins, and I can go with 50 bins, and I get a much more finely grained picture here, right? Yeah, there's somebody asking. That's a good point. Let me restart, clear it all, and then I push it. Yeah. With regard to the dates conversion, this was not too involved, but all the expressions have been pretty long, actually. So here, bash update. So this should now be, I always like to check. Data types, processing, calculating, collecting Apple stock data, visualizing the data, working with dates, right? This is now in the gist. So far as I've come, that's now all up to date in the gist. Let me re-execute it all. Run all cells. Should also here run selected, run all. And that's now the frequency distribution. We can copy this and have a look at the frequency distribution of the Apple stock prices, right? We see, yeah. Of course, this is now in prices, not in returns as we are used to, but something that we need to keep in the back of our head. So we can do a bit more. So I'm not deep into like having fancy visualizations here, but at least we can put a title, right, where we say here this is for euro US dollar. This will be the symbol, right? Euro US dollar. I can also here put a title. PLT title will be Apple. Oh, these are the rigs from Refinitiv, and we get the data visualized. Frequency distributions are typically used to visualize the returns, right? Maybe we try to calculate the returns here as well. So I would go with a log returns, calculation of log returns. Yeah, what are log returns, right? I have a price maybe S0 of 100 and S1 of 110. 110 and my log return now. Yeah, how do I calculate log returns here? Yeah, the logarithm. Where do we get it from? Yeah, you might guess it, you might know it since years, I don't know. Maybe from the module that I have used very briefly before, from the math module, right? Where I can now math log, and I have like the future return over, or the future price, sorry, the future price over today's price, which gives me the log return. It's slightly below the simple return, which would be 10%. The example is simple enough, right? So now let us calculate the log returns using a control structure, and I would say maybe a more traditional approach that you would implement in, let's say, compiled language, for example. So I can, for example, go and do the following: for I in range length of, what should we do, euro US dollar? Yeah, let me maybe do it for euro US dollar. Let's do it for Apple, for length of Apple, and the lengths are different, right? And I would like to do the calculation. Let me write here pass. I would need another object to here get the log returns collected, because I mean the calculation is one thing, but I could write here parentheses calculation and collection of the log returns. Not that I calculate them, forget them. I want to have them afterwards. So these will be, let me call them log returns. Or let me write it out, log returns. No, it's so long. It feels too long given what I've been doing before. Log returns as a list object, right? And now we can do the calculation as follows, and the collection LR append, we now put it here behind it, math log, right? And we go with Apple I plus 1 over Apple I. So this would be, right, in the first iteration, it would be apple 1 over apple 0, then apple 2 over apple 1, apple 3 over apple 2, etc. pp. So closing this and closing this. Let's see if this works. So APL, there's a naming error, obviously. List index out of range. I probably need to go just to the second but last one. And now we are good to go. You have seen I've added a -1 because here I go 1 beyond the final index. Therefore, it's enough to stop at the second but last index. I could also do the following and start at 1 without subtraction. Yeah, not to confuse too many things here now, right? So LR now has a bunch of values which are pretty close to 0. These are returns, right? And these are daily returns. So we would expect them to be pretty close to 0. Here and there, you see +2%, +2%, a few others, right? But not too many of them well above or below 0. So the first 7, let's say, we're having a look at. First 7 log returns. And this is now something indeed where histograms, frequency distributions often are used for the visualization. LR, the log returns as a histograms, and the bins also 50 instead of the default of 10, semicolon. And we now see the somewhat looking like a normal distribution, frequency distribution, but we know that in general, and here it's also obvious, I would say, from visual inspection, with a little bit of experience, that we are not dealing with a normal distribution. We are having returns here distributed with a high peak. So more than would be expected on the normal distribution of the realizations are close to 0. And we have the tail events, which are the large negative returns and the large positive returns here for the Apple stock over 10 years. So, right, we maybe put again here PLT title APL.O log returns as a frequency distribution. Yeah, seeing real world financial data, not fake data. This was real world end of day data that we have been working with. We have been focusing basically on 2 time series, the one for Euro-US dollar cross, and the other one on the Apple stock price. I think everybody can relate to these 2 quantities, to these 2 financial instruments. And so far, maybe you have noticed, maybe not, maybe that's something that you've been doing a couple of times, maybe never. But we haven't used any NumPy whatsoever, nor have we used pandas. Of course, matplotlib for the visualization, but I think these days when people start working with data files such as the CSV, they often dive right into the pandas world and use what we are going to use as well, read_CSV, etc., right? And do similar things with not pure Python, but rather the more sophisticated data science packages such as pandas, right? I mean, we have 1 minute left, and I mean, we can do one more thing, maybe a little tiny little thing. Oh, I was just like, you see, I was talking too much about NumPy and pandas. What just jumped to my mind, I have enough other examples, but what jumped to my mind was simple enough, but would require for me to have NumPy with. Therefore, maybe I skip that, given that we're 4 minutes. I'd rather wrap it up now. Here with the pure Python world, having now seen the data, having a good feeling, we can work with the data now in the other parts. A little bit more, not efficiently, but a little bit faster, right? You've seen it, you know how it looks like. when we process the data, when we work with the data, it should be already well known to you. So let me restart, clear all the outputs without my tiny little example, which would have required NumPy. So let's skip that one. As I said, I'm doing an update. Yeah, there's somebody asking about importing live data. This is something that I've had as an idea optionally as well. You see, we have lots to cover, so it's one of basically my favorite topics. Not that I'm against it, not at all. But to work with streaming and live data, maybe when we get to the pandas part, I think this is where it would make sense to have a look at live streaming data. If I might forget about it, as I said, I'm pretty happy to get feedback here that we together define and shape what we will be doing in the remaining time. Just remind me about live and streaming data. This is a good example, and I think once we arrive here in the part of pandas, once we know how we can deal with pandas, it might indeed be a pretty nice exercise to add live streaming data to the mix, something we focus on in other areas. But again, I won't go to an API which is live in the market. So what I would set up a tick data server from scratch that we can use and that we can interact with, and which runs 24/7, even on the weekends, etc. So that would be the approach. I see, others I think agree with regard to the live data. The latest versions are pushed. With regard to uploading of the resources, this might take a little bit, right, until videos are processed, etc. But I guess this is more a topic for those who weren't able to attend. But as far as I can tell, the questions have been answered so far. And I think it's a good point for me to wrap up today's session, first day of our online bootcamp. And saying happy Python for Finance coding. See you in the next session. You have links to all the resources. Go to webinar, the Quant platform, the gist, etc. So feel free to revisit, play around with it yourself, and make the best out of it. That's basically my best recommendation. See you in the next session. Bye bye.